Hello everyone, so here I'll be explaining my Michaelis-Menten plot and my Lineweaver-Burk plot and how I got to the values of the Vmax and the Km. So to plot the Michaelis-Menten plot, I used the given values, which were for substrate concentration, which was in millimolar, and for the rate of reaction, which was in micromolar per second. And this is the plot that I got. For the Lineweaver-Burk plot, I plotted the values of 1 over substrate concentration and the values of 1 over the reaction rate. And this is the line that I got. And then the equation of the line is here on the graph as well. So using that equation, we know that the y-intercept is equal to 1 over Vmax. So according to the equation, our y-intercept is 0.5239, which is equal to 1 over Vmax. When you rearrange the equation, you get that Vmax is equal to 1 over 0.5239, which becomes 1.909 micromolar per second. And for our Km, using the equation, we know that the slope is equal to Km over Vmax. Our slope, according to the equation, is 3.3268, which is equal to our Km over our Vmax, which is 1.909. When you rearrange the equation again by multiplying both sides by 1.909, you get that our Km value would be 6.350 millimolar. Okay, moving on to question 2. This one is a little different because we were given 2 different inhibitors as well. So for the Michaelis-Menten plot, I plotted that one for just the enzyme, which was the substrate concentration against the rate of reaction, and also went ahead to do a Lineweaver-Burk plot, which was for the enzyme alone without any inhibitors. So to calculate the Vmax and the Km for the enzyme alone, I did the same thing as I did in question 1, which was to use the following the equation of the line. So the y-intercept is equal to 1 over the Vmax. So for the y-intercept for that line would be 0.6752, which is equal to 1 over the Vmax. When you rearrange the equation, you get you calculate 1 divided by 0.6752, and you get that your Vmax is 1.481 micromolar per second. For the Km, we use the same thing again. The slope is equal to Km over Vmax. Our slope of the line will be 1.1022, which is equal to Km over the Vmax, which was 1.481. When you do that, calculate that, you get that the Km would be 1.632 millimolar. And then for the Lineweaver-Burk plot with the inhibitor, you can see that this is the plot. You get 2 different lines because one of the lines, the blue line, indicates the enzyme without the inhibitor, and then the orange line is the enzyme with the inhibitor. So for the Vmax and the Km for that inhibitor, we use the equation from that line, which is the orange line. So the y-intercept for that line is 1 over Vmax. the y-intercept for that line is 0.2701 is equal to 1 over the Vmax. And then when you do the math, we find that the Vmax for inhibitor 1 would be 3.702 micromolar per second. And then for the Km, slope is equal to Km over Vmax. So the slope for that line was 0.4409, which is equal to the Km over our Vmax, which was 3.702. And when you calculate that, we find that Km for inhibitor 1 is 1.632 also micromolar. And then for the second inhibitor, we got a different line, a different graph from the other two graphs that we got, but we still calculate the Vmax and the Km in a similar way. So the y-intercept is 1 over Vmax. That y-intercept for that graph is 2.0086 is equal to 1 over Vmax. When you rearrange the equation and calculate that, we get that the Vmax for inhibitor 2 is 0.498 micromolar per second. And for the Km, we do the same thing again. The slope of that graph is 1.2901, which is equal to the Km over the Vmax, 0.498. Calculate that by multiplying both sides by 0.498. We find that the Km for inhibitor 2 is 0.642 millimolar. Okay, so looking at the two graphs, looking at the Vmax and the Km for the two graphs, we'll go over here. So for inhibitor 1, I determined that this plot, the Lineweaver-Burke plot for inhibitor 1, indicated that inhibitor 1 is a non-competitive inhibitor. This is because the value for Km never changed. So the value for Km without inhibitor is 1.62 right here, and the value for Km with inhibitor 1 is still 1.632, which indicates the fact that it is a non-competitive inhibitor. Also, the shape of the graph also indicates that it is a non-competitive inhibitor over here in this spot. For inhibitor 2, I determined that inhibitor 2 is an uncompetitive inhibitor because the values for Km and Vmax, they decreased. So the original value for Vmax is 1.481 here, and then the value for Km was 1.632, and with inhibitor 2, the value for Vmax decreased from 1.481 to 0.498. So did the value of Km. It went from 1.632 to 0.642, which also indicates that it is an uncompetitive inhibitor.